Welcome back, and here we are talking about how to write names, or how to give the names for different ionic compounds. This is if you have the formula and you got to write the name. Now, let me just remind you of a couple things here while doing this. You should have a list of ions and their names, or you should know quite a few of the common polyatomic and monatomic ions and their charges. We should also be familiar with how to use the periodic table to determine charges of monatomic ions. If any of those are concerning to you, or you don't quite know what's going on, you can find the information in a previous podcast on ionic compounds. So let's get started with some of this. If you're given the formula for an ionic compound, one of the most important things to notice is this first piece right here of the formula. That's going to be a metal. As soon as you see that that's a metal that's given to you right there, then the compound is ionic. So there's some certain steps, that you need to follow in order to do this. The first step we're going to do here when writing the name from the formula is we're going to have to name the cation. That's the metal piece, or the first piece that's given in an ionic formula. So in this case, when we look at the formula, and these kind of formulas will always have two words in the name. So there's always going to be a name for the cation and then the anion, and sometimes there will be even the name or a Roman numeral to show the charge on the metal. So in this case, if you look at the formula, the metal that's given is Na. So when we look on the periodic table, or maybe we know this element has the name sodium, is what's used for that element. That's the symbol. Na represents the element sodium. So that's going to be the first part of our name. Now, one of the things when doing this that you might recall from some of the previous podcasts is if sodium is a transition element, meaning it's in the middle part of the periodic table, then we've got to do some more information. In this case, sodium is not a transition element. It's in group 1A, so we don't have to worry about those extra steps. We'll see how to do that a little bit later on. Now, the other piece in the formula, the other step of this, so step number 2, is to name the anion. We need to name the anion. Now, the anion symbol in this case is Cl, which is the element chlorine. However, if it's monatomic and it's by itself in a compound, the name of this is chloride. We change the suffix, as you might recall, to IDE. So therefore, if we look at the formula NaCl, the name of this NaCl would simply be sodium chloride. And that would be the complete name for that ionic compound. What about if we've got MgF2? We're going to follow the same steps. So the symbol Mg is the symbol for the element magnesium, and we don't change the name at all of the first piece. So magnesium is not a transition element, so all we do then is we move on to naming the second piece of the formula, or the anion, which in this case it's the symbol F all by itself, which is fluoride, is the name of that element. Now, a lot of students will look at that formula and they'll see this subscript 2 and be really concerned about how to include that in the name. The reason why there's a subscript 2 on that formula is because the charge of a fluoride is a -1, while the charge of a magnesium is a +2. Therefore, you need 2 fluorides in order for the net charge on this ionic compound to be 0. So the fact that the name of the compound is magnesium fluoride tells us that there has to be a subscript 2 on it. What about Na2SO4? Well, we're going to follow the same rules because that first piece, Na, is a metal. We just saw previously that Na is sodium, so we're going to stay with that as the first part of the name, sodium, and we don't need a Roman numeral since sodium's not a transition metal. SO4, that is the formula for the polyatomic ion sulfate. So the name of this compound, Na2SO4, is sodium sulfate. What about FeBr3? Now things get a little bit interesting. We're still talking ionic compound, so Fe is the symbol for iron. Br is the symbol for bromine, but when it's in a compound we change the suffix to IDE. That becomes bromide. Now, one of the things here that's quite different is iron is a transition element. So that means in the name we're actually going to get a Roman numeral. The Roman numeral, as you might recall from a previous podcast, is the charge on the iron cation. So if we go back to the formula, each bromine has a -1 charge, and we have 3 of them. That means the net negative charge is -3. Keep in mind that the entire formula, this whole formula here, has to have a charge equal to 0. So that means if the bromine is a -3, the iron has to be a +3. So therefore, in order to show that, we actually put the Roman numeral 3 in parentheses in the name. The 3 tells us the charge on the iron, so we get iron 3 bromide. A little harder yet still, Fe2O3. Now our metal, our cation, is still iron, so that's good. That hasn't changed from the previous problem. The second part of the name is oxide, and iron is a transition element. It's in the middle part of the periodic table, so we do need a Roman numeral. Each oxide is a -2. And in our formula, we have 3 of them, so the net negative charge is -6. That means the net positive charge has to be +6, but there's 2 irons, so if we divide 6 by 2, we get the fact that the iron has to have a +3 charge. So this name of this compound is iron 3 oxide. Well, hopefully that's been helpful. And here's some of the different ways we can put together ionic names and formulas. So what I'd recommend you do is I'd recommend you hit pause on this screen, try these 4, and then come back in a couple minutes and see what they end up looking like. Welcome back. If you did actually hit pause, here's what the formulas look like. Ammonium phosphate would be NH4 in parentheses 3 and PO4 outside of parentheses. That's ammonium phosphate. Lead 2 sulfate would be PbSO4 would be our formula there. K2CO3 would be potassium. And then carbonate. Potassium carbonate, and AlC2H3O2. There should actually be a subscript 3 right there. Sorry about that. This should be aluminum acetate. Well, I hope this has been helpful on figuring out how to write the names and formulas for ionic compounds. And, you know, if you need any more help, stop by, send an email, find one of us chemistry teachers here, and just let us know what we can do to help you out. Good luck with writing names and formulas of ionic compounds.